Hello, this video is going to be an overview of the circle constant. The circle constant, as we all know it, is pi, which is equal to the circumference divided by the diameter. It is the same for all circles and is equal to 3.14159 ... However, many people have been arguing lately that it's not the diameter that's important about a circle, but rather it's the radius. And therefore the circle constant should be defined as the circumference divided by the radius. This new circle constant would be tau, and you can see the symbol for it right here. Equal to the circumference divided by the radius, it would be equal to 2 pi. Well, it seems like a very small and meaningless change, and on one degree it is, in the sense that it doesn't actually change what math is telling us. It does have some important implications, and we'll look at just some intermediate level math to see why. First, we're going to need to remember that the diameter is equal to twice the radius, and the radius is therefore equal to half the diameter. We'll look at the area formula, which I'm going to assume that you all know, is pi times radius squared. Now, this seems like a very simple formula, and it is. However, it's inconsistent. This is because pi, defined as the circumference divided by the diameter, is based upon the diameter. However, then it uses the radius in the same equation. If we decide to show what's really going on, you can say that it's the circumference divided by the diameter times r squared, and then change r squared into the diameter divided by 2, and then show that when pi is used with respect to the diameter, we find that the area of the circle is equal to pi times the diameter squared divided by 4. Going back to what I said earlier, the reason why the radius was used originally is because the radius is considered more important by most mathematicians than the diameter. However, if the radius is more important, then our circle constant should be based upon the radius. This would mean changing the equation that we all know as the area is equal to pi r squared to tau divided by 2 times r squared. Now, tau divided by 2 is more complicated, it seems, than just having pi. And in this case, the equation does seem simpler, although it obscures truth as well as the beauty behind the mathematics. We first can see that when we use tau and r squared, we are being consistent in that we are relying upon the radius throughout, which is not the case with the typical area formula. And it's also, this formula is no more complicated than when we truly show what the area formula with respect to pi is. This 1/2 also has a lot of mathematical significance. Some of the reasons behind that are fairly complicated and involve things such as calculus, although the significance of the 1/2 can also be demonstrated just by simple geometry. Rearranging everything, we can find that the area is equal to the circumference times the radius divided by 2, which resembles the area of the triangle, which is equal to the base times the height divided by 2. This means that the area of a circle with a given circumference and radius is equal to the triangle with the base of length c, which is the circumference, and of height r, which is the radius. While using tau in this case provides more mathematical clarity, the dominance of tau truly shines in trigonometry, which we'll go over next. Watching this video, you may or may not have already learned some basic trigonometry, but whether or not you have isn't very important because essentially it's going to go back and relearn everything. Now here we have a circle with radius r. Now, one of the first things you need to understand about trigonometry is the idea of radians. Radians, or 1 radian rather, is the length along the circle that is equal to the radius. This concept is used to define angles, similar to the common system which we all know, called degrees. 360 degrees is all the way around the circle. The problem with this system is how arbitrary it is. Any number could be used and would be about as well functioning. When you use radians, it's very natural. 1 radian is the angle in which the length of the circle covered, I'll thicken this, is equal to the radius. If the radius is 1, then this length here is going to be 1, and the angle is going to be 1 radian. Now, of course, there's going to be other ways to define angles, but to a point you're just going to have to take my word that this is the best way. There's some mathematical justifications, but it takes a long time to get into. So we're just going to go with this is the best way to measure angles. So once you first get your head around this concept, you're then probably going to want to figure out a good way to convert between radians and degrees. A simple place to start would be, what would be the equivalent of 360 degrees? Or how many radians would be all the way around the circle? If we're going all the way around, then you're going to be looking at the circumference C. But how many times do you go the distance r? In other words, divide by r. Now, because pi is defined as circumference by 2r, all the way around is going to be 2 pi. However, before I write anything down, I'm going to remind us about tau. Tau being defined as circumference divided by the radius. Now, this is going to make things a lot easier because I'm just going to erase some stuff quick. Alright, so anyway, using tau, everything is going to be much simpler. And there's going to be a missing factor of 2, which, as many people know, if they've taken trigonometry, can be very distracting. Now, if the angle is 0, in terms of radians, even though it's the same in degrees, then the distance along the circumference is 0. We'll write 0 degrees is there. Then, as we go a quarter of the way around the circle, that's going to be a fourth of tau, because once again, tau be all the way around. Halfway around the circle, once again, in respect to the radius, is tau divided by 2. 3/4, 3/4 tau. All the way around is tau, which, if you study basic trigonometry, you'll understand how that is the same as 0 in this case. Now, this is very straightforward. All you have to remember, a quarter of the way around the circle, tau over 4. Halfway around the circle, half of tau. All the way around the circle, it's all of tau. Of course, tau isn't what's traditionally used. It's pi. And that's going to make things more complicated if we try to look at what happens when you use pi. Now, here we have the traditional trigonometric circle, which, if you've taken trigonometry, you've obviously seen. The thing about this is it's not very intuitive. A quarter of the way around the circle is a half of pi. All the way around the circle, is pi. 3/4 is 3/2. And all the way around gives us 2 pi. Now, if you haven't taken trigonometry before and you're just struggling to try and follow along, obviously tau is going to be far simpler. Because, I'm going to repeat this one more time, quarter way around the circle is a quarter of tau. And if you have taken trigonometry, while it's more familiar, I'm going to go ahead and assume that you do understand how tau does make this simpler. In fact, there's no debating that tau, in this case, is superior to pi. Even the most adamant supporters of pi would admit that tau, in this case, does make the math simpler. This is just one example of countless examples, mathematical examples that are, of how superior tau is. This is just simply one that is easier to demonstrate. Now, many of you watching this, assuming you understand what's going on, would probably be wondering what you should do, because clearly using tau makes the math simpler. Unfortunately, nearly the entire world uses pi, and so it's a good reason that your teachers taught you pi and not tau, even though it makes it significantly simpler. The fact that the entire world uses pi makes it difficult, although you can try thinking in terms of tau. Or if it makes it simpler, just try thinking in terms of 2 pi, which is fairly likely that if you've taken trigonometry, you're already doing. You just haven't realized it. Also, if you want, you can do your own research, and you'll be able to find countless resources which will explain more about all this stuff that we've already covered and countless other topics. And if you want, you can look up other resources that are already well throughout the internet. Tau, spelled T-U-A, while has been around for a while, is relatively recent in its popularity, although you'll be able to find many resources that will help to explain this in better depth if you're curious. I do also have other videos which obviously would serve as another great resource if you're curious on either a slightly simpler explanation of all this or more in-depth.